Inshallah, in this part, we are going to continue the higher order linear differential equations. Before going to the next questions, let me revise the concepts which we already have done in the previous classes. We have done the questions based on complementary functions. Just recall this one, revise this one. If m has distinct values, then complementary function formula is yc equals to c1 e power m1 x plus c2 e to power m2x. If two we are having two values, then this or three values means plus c3 m3x, so on. Second case is when m has repeated roots or equal roots or same roots, then the formula for complementary function is y yc equals to c1 plus c2 x into e power mx. If m is complex, then alpha plus or minus beta or imaginary, then the complementary function is yc equals to e power alpha x into c1 cos beta x plus c2 sin beta x. In the same way, for particular integrals, we have done questions based on 5 methods. Just we revise this one. The first one is when we have e power ax. The formula will be 1 by f of d e power x equals to 1 by f of e. Particular integral can be find out by using 1 by f of e. That is, in place of d you must keep a. But if f of a equals to 0, 1 by 0 is not defined. Therefore, in that case, then multiply numerator by x and differentiate denominator with respect to x. And differentiate denominator with respect to x. Now, type 2 is when we get sine x or cos x. Then the method is, we have done the questions already, this one. Put d square equals to minus a square. In the same way, if f of minus a square equals to 0, this is not defined. Therefore, multiply numerator with x and differentiate denominator with respect to not x, with respect to d. So, next one is case 3, type 3 questions. When we get algebraic x values, x or x square or x cube, we have to use binomial distributions. For that, we are using the formulas binomial theorem expansions. Okay, 1 minus d whole power minus 1 is 1 plus d square plus d cube plus so on. In the same way, 1 plus d whole power minus 1 is 1 minus d plus d square minus d cube plus so on. In the same way, 1 minus d whole power minus 2 is 1 plus 2d plus 3d square plus 4d cube. 1 plus d whole power minus 2 is 1 minus 2d plus 3d square minus 4d square. And type 4 is when we get some function with e power ax. With e, if we get some function, then the formula is when we take out this e power x outside, this d will become d plus a. So the formula will be 1 by f of d e power x into e equals to e power x into 1 by f of d plus a into, that is, we have to keep in place of d plus a. And the last, type 5 is 1 by f of d into x. With x, if we get some function, then the formula we have used in the last part is x minus f dash d by f of d into 1 by f of d into 1 by f of d into d into 1 by f of d into d. So these types of questions we already covered in the last part. But in some questions, in one question, if the long question is there, we may get 2-3 combined questions based on type 2 also, type 3 also. So let me do 1-2 questions in which in one question we may get 2-3 methods. Let me try for that questions. Now see here, one question I wrote on the board. So let me start. How to start, you see, first we have to take the auxiliary equation to find the complementary function. So let me start like this. Solution. Auxiliary equation is, in place of d we write m square minus 2m plus 1 equals to 0. Either you solve by factorization or you use the calci, you will get m values to m minus 1 into m minus 1 equals to 0. If you factorize this one, therefore m equals to 1 comma 1. So we get two same values. Therefore complementary function is, we are having formula for two equal values. Just now we had revised the concept, c1 plus c2x into e power mx. M value is 1, so 1 into x will be x. So this will be yc equals to c1 plus c2x into e power 1x. 1x will be x. Now we got the complementary function. For particular function, particular integrals must bring d that side. What is here? 1 divided by d square minus 2d plus 1 into x square e power 3x minus sine 2x plus 3. We can do continuity, we can continue this one. Okay, let me separate this one. Y equals to, write this with all the three functions. We can write like this: 1 divided by d square minus 2d plus 1 into x square e power 3x minus 1 divided by d square minus 2d plus 1 into sine 2x plus one more step we have to write one. 1 divide, I'm writing here 1 divided by d square minus 2d plus 1 into e. I'm taking separately. Let first we find the particular integral of this function, then this function, then this. After it, we can add 3. Also, I'm doing separately because to explain it clearly, I want to do it separately. So let me first find this one, then this, then this. Okay. Let me note this as equation 1. When we complete all the 3, let me add that. Okay. So the first one is solving. Let me take this y p1, first one. What is its value? 1 divided by d square minus 2d plus 1 into x squared e power 3x. Let we use the method. Let we use the method of some function with e, some function x squared with e. What is the formula we have done? 1 by f of d into e power ax into v. When this e power ax will get outside, what is left here? In place of d, we must write d plus a v. In place of d, we must write, sorry, in place of d, we must write d plus a. So let me take out e outside. So we have to change d equals to d plus a. D plus a means the power of e. E power ax, the coefficient of x, 3. So in place of d, we must write d plus 3. So yp1 equals to, take out e outside. So this d will become this. If you take 3 of e power 3x outside, this d will become d plus 3. So we can write like this: d plus 3 whole square minus 2 into d plus 3 plus 1 into, what is left here? X square. Now you first expand this. Okay, so what will be left here? Equals to e power 3x into 1 divided by a square means d square plus 2ab. 2 3 is a 6d, and here we are having minus 4d. So 6 minus 2, sorry, 6 minus 2 is 4d. Let me see the constant. 3 square 9 minus 6. 9 minus 6 is 3. 9 minus 2 3 is 6. 9 minus 3 6 is 3 plus 1 is 4. So into x square. Let me write like this. You see here, this can be written as d square plus 2 into d plus d square, 2 square, sorry. This we can write like this. This is the formula: a square plus 2ab plus b square. 4 is 2 into 2, 4 is 2. So a plus b whole square. So we can write like this: e power 3x into 1 divided by d plus 2 whole square into x square. Now for x square x cube, we have to use binomial distributions. Binomial expansion, sorry. For binomial expansions, we must not have 2 here, must have 1. So let me take common here. So this will be e power 3x into 1 divided by, if you take 2 common here, actually it is 2 square because you are having square. So here it is left with 1 plus d by 2. 1 plus d by 2 whole power 2 into x square. Now you bring this upside up in the numerator, this plus 2 will become minus 2. This is 2 square 4, let me write here. So we can write like this: e power 3x divided by 4, e power dx divided by 4 into 1 plus d by 2 whole power minus 2 into x square. Now let me expand. What is the formula we are having? 1 plus d whole power minus 2 is, its formula is 1 minus 2d plus 3d square. We write only up to d square because x square is there, no? The terms above d square will become 0. Therefore, we expand up to d square. So let me change this one: e power 3x by 4 into, what is the formula? 1 minus 2 into d is d by 2 plus 3 into d square means d square by 2 square is 4 into x square. Now you multiply 1 into x square, e power 3x by 4. 1 into x square is x square minus d of x square plus 3 by 4 d square of x square. Now two steps are left. Now what is the meaning of d of x square is differentiation to x. Again d square means one more time if you differentiate to x will become 2. So let me stop here. Last step you see here, e power 3x by 4 into x square minus, watch carefully, d means d by dx of x square is 2x. Now here you see here 3 by 4, 1 by differentiation we get 2x, one time differentiation. Again if you differentiate we'll get 2. So you here your second time differentiation is 2. 2 ones are 2 twos are. So what is left here? 3 by 2. So let me write this plus 3 by 2. Whether we take LCM or not, no problem. So we got this. Next one, suppose second term. Okay, in the same way let we continue with for the third first integral we have solved. You watch carefully. Now we have, suppose this one we have taken this term and also no we got the answer. Now let we solve the second value. Let me solve the second value. What is the second value we are having? Second value we are having sine 2x. Okay, let me continue this one. See here, I'm continuing here. Watch carefully. Now the second one is minus 1 divided by d square minus 2d plus 1 into sine 2x. We already discussed now for sine and cos. What is the method? Method is we have to keep d square equals to minus a square equals to minus sine ax. A is 2, 2 square is 4. So in place of d square must write 4. So this will become minus 1 divided by 4. 4 plus 1 will become 5 minus 2d into sine 2x. We already done these types of questions in the part 2, part 3. You go ahead there to see the complete methods. Okay. Now here again we have to make d square. Again we have to make d square. So we have to use its conjugate and multiply. A minus b conjugate is a plus b. So to make this d square, a minus b into a plus b is a square minus b square. So multiply with a plus b, 5 plus 2d on the numerator and denominator. Minus 1 into multiply with 5 plus 2d in the numerator and also in the denominator. 5 minus 2d into 5 plus 2d and into sine 2x. Now I'm continuing here. Minus into plus is minus 5 into sine 2x minus 5 sine 2x. Minus into plus is minus 2d into sine 2x. Now in the denominator what will happen? A plus b into a minus b is a square minus b square. A square is 25. B square, 2 square is 4d square. Again you keep the value of d square. What is the value of d square? Minus 4. If you keep here minus 4, if you keep here minus 4, minus minus plus 4 for the 16. 25 plus 16 will be 41. Let me take out common. How? What will we can take common? 1 by 40. I'm writing this d square is minus 4. So if you keep here minus 4, minus into minus plus 4 for the 16, 25, 41. Now minus 5 sine 2x. Now watch carefully. D by dx of sine is cos 2x. D by dx of sine is cos 2x. But again, we have to differentiate 2x. That 2x will become 2. D by dx of x 1. 1 into 2 is 2. 2 2s are 4. So this will be minus 4 cos 2x. Cos 2x. We do one thing. Let we just take minus common outside. If you take minus common outside, this will become plus. So this is the answer for the second term. Let me solve the third term also. Now see here the next step. Suppose you see here, for constant we have already done one question. With constant also we must assume e power 0x so that we can do the question based on e power ax. Always when we get constant, you multiply this with e power 0x. E power 0 is 1 only, 1 into 3 only, 3 only. But we can now use the concept of e. What is the concept of d? In place of d must write a. What is the value of a here? 0. So in place of d we must write 0. If you write 0, what is left here? yp3 equals to yp3 equals to, if you keep 0 here, 0 minus 0 will be 0, 0 plus 1 will be 1. So it will be 1 by 1 is 1 into 3 into e power 0x. Again you take out 3, 0, e power 0x. E power 0x will be 1, 1 into 3 is 3. So third one we got 3. Therefore we must write like this. Complete solution. Complete solution is What is the method we are having? Y equals to yc plus yp. Yp we are having three terms, yp1 plus yp2 plus yp3. So lastly, y equals to what we got here, yc we got c1 plus c2x into e power x plus yp1. Just here you see still it is there on the board. See, this is yp2 p1, sorry, yp1 is e power 3x by 4 into x square minus 2x plus 3 by 2 plus yp2. Yp2 is just here, you see here, I think this is the yp2. So this is minus 1 by 41. The place is so less, so I'm trying to complete here itself. Minus 1 by 41 into 5 sine 2x plus 4 cos 2x plus yp3. yp3, so what is the yp3? Last just now we got the value of yp3 is 3. So this is one question I have taken on the board. In this way you also practice 2 3 more questions based on the same method. Means when the question sometimes there are 2 3 functions will be given like this. Here you see here this type of questions, when you get, you try separately. First you find this using whatever the method, then this like this questions you practice 1 or 2 more questions, inshallah. So in the next class we are going to deal with the variation of parameters, very important concept. So if we start now itself, the video will become so lengthy. So let me continue it in the next class to find a very important method, that is very important concept, question solving on the basis of variation of parameters, inshallah, in the next class.